Hello students, welcome to BYJU'S exam prep, most comprehensive app for all exams. And then today we are going to discuss complex power, right? And what is the complex power and how to calculate the complex power. And this is very important topic from circuit theory, that is what? Network, right? Now power triangle and complex power. First of all, inform me that sound quality, picture quality, everything is fine. Okay then. Now my introduction, myself Sanjay Rathi. I am having around 20 plus years of teaching experience in the field of competitive exams like EAC, GATE and PSU. And I have qualified and selected for engineering services exam. These are my ranks: AIR 16 in EAC 2005 and AIR 21 in EAC 2008. Right? And I have mentored more than 1 lakh students for these exams. Now, what is complex power? Which type of questions, right? Apparent power, reactive power, effective power or useful power, power factor, what is the IRMS value, VRMS value, each and everything we will discuss in this session, okay? And with important numericals. So now what is the effective or RMS value? First of all, how we can calculate the effective or RMS value, right? So what is the meaning of the effective or RMS value? The effective value of a periodic current, effective value of any periodic current is the DC current, that delivers the same average power to a resistor as the periodic current, right? So that is the proper definition of RMS value. And then the effective value of periodic signal is its root mean square value, that is IRMS or VRMS. That is also called effective value or IRMS value. Sometimes we are calculating, that is the formula for this IRMS. So what is the period of that? Let the time period of any waveform is t, that is the integration 0 to t square of that term dt, and the root of this term will give you the IRMS. Or if suppose you are representing in terms of angle, then it will become 1 by 2 pi, 0 to 2 pi, right? It is any signal Vt or It square d omega t raised to power half. This is also the IRMS value. It depends on x-axis. If you are taking the t as a variable, then that is the formula. If you are taking the omega t as a variable, then this is the formula. This is the IRMS. Now, one question, just like what triangular wave, square wave. Okay, so now, for example, for any sinusoidal wave, if we are using the formula, that is the case, that the peak value is Vm 0 minus Vm, then for this sinusoidal wave, the RMS value is VRMS is equal to, tell me, that is the peak value divided by root 2. Peak value divided by root 2 by using the same formula. By using this formula, VRMS is equal to 1 by t 0 to t I square t d omega t dt. Or if you are using this term omega t, then this will become angle 0. This will become pi. This will become 2 pi. Right? And that signal is, what is the signal? Input is Vm sine of omega t, right? That is the Vm sine of omega t. Then simply use this formula, VRMS is equal to 1 by 2 pi 0 to 2 pi Vm square sine square omega t, right? That is the square d omega t, and root of complete value 1 by 2, and please square it and get the answer, and you will get the Vm by root 2. That is simple. Okay, so that is the use of this formula. In this way we can find the RMS value. Similarly, for any triangular wave, what will be the RMS value? Let, for example, that is given one question. Find the RMS value of the current waveform of the figure. If the current flows through a resistor, this resistor, current flows through this particular resistor. For any triangular wave, let the peak value is what? 16. Here it is a 16, 0, 1 and what? 2. What is the time period of the signal? If it is in second, so for every 2 seconds it will repeat. So please give me the comments. What is the time period of the signal? In comments box, give me the comments. What is the time period of the signal? Now the time period of the signal will become 2 seconds, right? But always remember what is the slope of this line and what is the slope of this line. This is a symmetrical way. Rising time and fall time is equal. The slope of this line, is what? 16. 16 minus 0 upon 1 minus 0. In this way we can calculate the slope. 16 minus 0, y2 minus y1 upon x2 minus x1, that is the 16. And the slope of this line is minus 16. 0 minus 16 upon 2 minus 1, this is the positive slope, that is the negative slope. Now try to understand, when we are increasing it, it will intercept at which point? Because at 1 it is intercepting at 16, and therefore at 0 it will intercept at what? 32. My dear friends, I can give the value IT is equal to 16t for 0 is less than t is less than equal to 1, and it will become after 1 is less than t is less than 2. We can define it. What is the slope? Minus 16. What is the interception? This is the t plus what? 32. That is the interception. So in this way we can write the equation to 16, that is, try to understand exactly at 1, put the t equal to 1, minus 16 plus 32, you will get the 16. You will get the 16. Always remember that y means what? Y is equal to mx plus c. If we want to get the interception, first of all write what is the slope? Minus 16. What is on y axis? T. And what is on y axis? What is the value? I. And x axis t plus c. If you want to know the interception, then exactly at t equal to 1, what is the value? We have the idea 16. Put t is equal to 1. What is the value of I? 16. And right here 16 is equal to minus 16 into 1 plus c. From this you will get the interception, that is what? 32. Okay, that is another method. One method from the graph. In this way we get the equation of this line. Interception is 0. Always the equation of the line is given by y is equal to mx plus c. So for first portion interception is 0, the slope is 16, and that's why the equation becomes 16t. For second one, 1 to 2, right? Slope is minus 16t, but what is the interception? From the graph we can get the 32, or you can use this formula. Exactly at 1 we have the value 16, put here, and you can get the c is equal to what? 32, and that is the equation. Once you will get the equation, just I am giving you the formula, right? Once you will get the equation, this is the IT. You have to get the IRMS is equal to 1 by t. What is the time period? 2. 0 to t integration, right? We have to divide it into what? 0 to 1. What is the value? 16t, square of this dt. And limit is what? 0 to 1 plus 1 to 2, square of that, minus 16t plus 32, square of this dt. Okay, integrate it. 0 to 1, 16t square dt plus 1 to 2 minus 16 plus 32 the whole square. right? And then 1 by 2, and then what, 1 by 2, you will get the answer for this question. That is the formula base. Because what is the IRMS? This is not the half, yes, this is 1 by t. I am writing the equation 1 by t integral of what, I square t dt. What is the limit? 0 to t, and then 1 by 2. Simply because the limit 0 to 1 and 1 to 2, split it into two parts, we have the equation, you can. But finally you are going to get IRMS is equal to, what is the peak value of this? The 16 divided by root 3. That will be the answer. We have the answer. IRMS for triangular wave is given by Im by root 3. Please verify this result. Check my calculation. Verify this result, right? No doubt. In exam hall, we will use what? Im by root 3. For any triangular wave, Im by root 3. For sinusoidal wave, peak value divided by root 2. So directly we can use, but here you can verify it. Please get the answer. Try to solve all this type of question. Okay. Yes, this is the answer. 16 by root 3 is the exact answer for this question. But we are getting the idea how to write the equation for this. Now, what is the complex power then? Now, this is about the IRMS value. Now, what is the complex power? My dear friends, in network or circuit theory, when we are dealing with the sinusoidal signal, right? And when we are passing that signal through any type of network, we are having in network, we are having what? Sometimes we are having the resistive element, reactive elements, like this is the resistor, this is the inductor, this is the capacitor. Here we are providing the voltage, okay, and this is R, this is L, this is C. Because the impedance because of the inductor or in steady state is given by j omega L, impedance because of the capacitor is given by minus j by omega C. So total impedance Z is equal to R plus j omega L minus j by omega C. So impedance has two parts, real part and imaginary part. Just I am giving you one example for series RLC circuit. Impedance has series two parts. One is what, real part, and one is what, imaginary part. Means it has some magnitude. Yes, we can calculate the magnitude, as well as what, angle, theta. If there is an angle, if now I want to calculate the current, here, I, then definitely this is the V, and I want I, then V by what, Z, and there will be a phase difference between voltage and what, current. Current may lead the voltage or current may lag the voltage. Okay, so when current lead the voltage, that is called resultant current, right? Then circuit is called leading circuit. Circuit is called leading circuit. So always remember, when resultant current I leads V, circuit is called leading circuit. Leading circuit, and that particular circuit is what, capacitive. That particular circuit is what, capacitive circuit. If when current and voltage are in phase, right? So when voltage and currents are in phase, then we are simply saying, normally it is represented in phasor. So sometimes you will watch current and voltage are in phase, or here in terms of time domain you will get the in frequency domain. 1 minute. This is called frequency domain representation. I leads V. I and V are in phase, then the circuit is what, purely resistive. Right? Third case, I lags V. Then if I lags V, then we are saying that that circuit is what, lagging circuit. Circuit is called lagging circuit. or this is the inductive in nature. What is this? This is inductive in nature. Okay, and now try to understand. We have one factor, you have idea about that, that is called power factor. Power factor, right? This is represented by PF. This is what power factor is equal to cos of theta, or sometimes it is written as cos of theta v minus theta I. Theta v minus theta I means the phase difference between voltage and current. The phase difference between voltage and what? Resultant current. Resultant current. So we are representing Vt. For example, I am representing Vt. Vm. Try to understand. Cos of omega t plus theta v. That is the representation in time domain, and It I am representing. This is called peak value, Im, here Vm, cos of omega t plus theta I. Watch these two equations. Its phase is what? Theta v, its phase is what? Theta I. Now that phase difference is what? Theta v minus theta I. That is called phase difference between voltage and what? Current. And cause of that factor is called power factor. A power factor is leading. Power factor is leading when I leads V. Power factor is lagging when I lags V. And power factor is exactly equal to 1 when both the voltage and currents are in same phase. So if the theta v minus theta I, in this case, in pure resistive case, theta v minus theta I is equal to 0. Therefore, power factor, that is nothing but cos theta, will be what? 1. Maximum. Maximum, right? So that is the value. Now, what is the role of the complex power? Just in this session, we are going to discuss only the complex power. So what is the complex power? So because that impedance is what? Not purely resistive. Not purely resistive. It may be capacitive or it may be inductive, right? And that's why we are getting the phase difference between applied voltage and resultant current. And that's why that ideal condition that theta will be 0 or cos theta, that is the power factor, will be 1. It is a very rare case. That practically not possible. Practically not possible. It means we have useful power if voltage and currents are in phase, but if they are not in phase, we have useful power, that is called resistive power, reactive power, and what? Apparent power. So that is the concept is given by the complex power. So complex power is the product of the RMS voltage phasor and the complex conjugate of the RMS phasor. So what is the meaning of this? Complex power S is given by VRMS IRMS complex. Complex conjugate of IRMS. Okay. For example, in my example, if suppose I am representing this is the Vm cos of omega t plus theta v, then this in phasor, this V is represented by Vm. I am taking cos as a reference, angle will become theta v. When I am writing I is equal to what? Im, angle will become theta I. Right? From these two equations, if you want VRMS, this will become Vm divided by root 2, angle will remain same theta v. IRMS, Im divided by root 2, that is called RMS value, into what? Theta I. What is the IRMS complex? Im divided by root 2, right? And what is the meaning of the complex? This angle will become theta I minus theta I. And when I am multiplying these two, VRMS, IRMS, complex conjugate, that is called S, multiply these two, you will get the Vm Im divided by 2, that is nothing but V effective I effective, and this angle will become theta v minus theta I. theta v minus theta I. This is called Vm by root 2 means V effective. Im by root 2 is called I effective or I RMS value. Angle will become theta v minus theta I. Theta v minus theta I. Very, very simple thing. Now, this is given in what phasor? Now we can write in complex. This V effective, I effective is nothing but IRMS, VRMS, IRMS and VRMS. Then complex power will become, there is two parts, V effective, I effective, cos theta. First part, cos theta V minus theta I, cos theta V minus theta I. Are you getting me? Theta V minus theta I. Okay. And then what is the imaginary part? That is the plus J. V effective, I effective, cos of, sine of theta V minus theta I. It is visible to you, everyone? Yes. Theta V minus theta I. So it has two parts, real part and what imaginary part. Now real part S is equal to P. This is called completely is called P. This is nothing but useful power or effective power or resistive power plus what? JQ. Plus what? JQ. That is the representation of the complex power. That is the representation of the complex power. So here P represent resistive power, that is the real part, and Q represent, just Q represent reactive power. Okay, so that is the sine theta V minus theta I. This is the cos theta V minus theta I. So what is the P? V effective, I effective, this much. What is the Q? V effective, I effective, sine of theta V minus theta I. Theta V minus theta I is the phase difference between voltage and current, voltage signal and current signal. So this is the value. Now the magnitude, what is the, there is a third power, apparent power. If you want to calculate the apparent power, magnitude of this will give you the apparent power. Apparent power, this magnitude means what? VRMS, IRMS, or we can show V effective, I effective. This is called apparent power. V effective, I effective is nothing but magnitude of this. This is nothing but S, the magnitude. What is the magnitude? If you have the formula, directly you can calculate the P square plus Q square. P square plus Q square. That is called magnitude. Now, if you want to calculate, the power factor, suppose this equation is given S is equal to P plus JQ. Now, if you want to calculate the power factor, so what is the S? What is the magnitude of the S? Root over P square plus Q square. What is the value of the P? Magnitude of P, V effective, I effective, this much. V effective, I effective means what? VRMS, IRMS. VRMS, IRMS, VRMS, IRMS cancel out, and that will give you the power factor. That will give you the power factor, means we can write what is the P? Mod of S cos of what? Theta. Where theta is theta V minus theta I. You will get the value of the power factor, that is nothing but cos theta P by mod of S. P by mod of S. And that's why this complete topic is very, very important, and what very simple. Get the formula of complex power and you will be able to solve any type of questions. Okay, then that is about the power, and now I will plot that P plus JQ. So that is the, if you want the PDF, join my Telegram channel, that is Electronics by Sanjay Rathi, right, where I will upload this PDF so that you will get the command over this topic, complete summary about what complex power. So what is the complex power? P plus JQ, VRMS, IRMS, complex conjugate of IRMS. We will get the VRMS, IRMS, already I have given. Apparent power means magnitude of that. Real power means S of cos theta V, theta minus. Reactive power means imaginary power, imaginary. And the power factor is P by S. This is the P by, we can say, the mod of S. Okay. Then, if you want to calculate S. We can calculate the S by using what? I RMS square. This is the impedance. Or impedance has two parts, resistive and reactive part, that is the value. This will become I RMS square R. This is called real part. I RMS square into what? X, that is called imaginary part. We can conclude P plus what? JQ. Now we are getting new information from this. New information from this, that we have the idea P is equal to what? VRMS I RMS cos of theta V minus theta I. Q is equal to VRMS I RMS sin of theta V minus theta I. Here I am using the positive value, then Q will be positive. If I am using the negative value, the Q will be negative. If in impedance, if the reactive part is positive or imaginary part is positive, then tell me, this is what? Inductive or capacitive? This is inductive or capacitive. If I am having the R is equal to, impedance is equal to Z is equal to R plus J omega L. This is inductive. If this is inductive, you will get the Q positive, right? And if Z is equal to R minus J by omega C, this is capacitive. In this case, you will get the Q less than 0 or negative. Or if it is purely resistive, means what? Q is 0. Q is 0, right? So that is the logic. So they give 0 for resistive loads, unity power factor. Q is less than 0 or negative for capacitive load, means leading power factor. And if the Q is greater than 0, directly we can say it is an inductive load and the power factor is lagging. Power factor is lagging. This is very, very important information about that P plus JQ. P will give you the effective power, Q will give you the reactive power. Now, what is the unit? Always remember, the unit of the apparent power is volt ampere. Apparent power is volt ampere. Unit of the real power, volt ampere is not the unit. What is the unit? Watt. This is the volt ampere, this is the watt. This is the real power, and volt ampere reactive. Volt ampere reactive is the unit of what? Reactive power, right? Watt. So normally that effective power we have to calculate, sometimes reactive power we have to calculate, sometimes apparent power, right? And last concept, that is called power triangle. What is the power triangle? So remember this, whether it is a resistive, capacitive or inductive. So what is the power factor? So power factor is a dimensionless quantity. P by S. P is the power, S is the power, power cancel out. It is a dimensionless quantity, simple cos theta. The power factor is dimensionless since it is the ratio of the average power to the apparent power. Average power to the apparent power. Cos theta is equal to P by what? S. The power factor that is written here is the cosine of the phase difference between the voltage and current, yes. And it is also the cosine of the angle of the load impedance. Yes, why we are getting the phase difference between? Why we are getting the phase difference between voltage and current? Because of what? Impedance, right? Because the impedance is not purely what? Resistive, not purely resistive. It has inductive part or what? Capacitive parts. That's why we are getting the phase difference between voltage and current. If we have the idea about what is the angle, that this is the Z, angle theta Z, and directly you can say what is the power factor? Cos of theta Z. Directly. Leading or lagging, it depends. If it is positive, that is lagging because it is inductive. If it is negative, capacitive, means what? It is leading, right? Remember that. Remember that. Okay, so that is the cos of theta Z. Directly we can get the magnitude of that power factor. Now this is called power triangle. What is the power triangle? We have the value P plus JQ, that is equal to what? S. What is the S? Root over P square plus Q square. Simply Pythagoras theorem, this is the light, this is the P, this is the Q, and this is we are getting the S. This is called power triangle. This is the Q, and that is the magnitude. S is equal to root over P square plus Q square. Now this angle theta is nothing but what? It will give you the value of, right? If suppose I want to calculate this theta, so this is what is the cos theta? Tell me, for this power triangle, cos theta is given by P by S. That is nothing but what? Power factor. Power factor. This is theta is what? Phase difference between voltage and current. So this is very, very important diagram, that is called power triangle. Now if suppose I want to represent it on this diagram, remember that if this is the P plus JQ, P plus JQ, watch this diagram. Let the P is the real part, this is the, I'm giving P plus JQ, 3 plus J4, that is nothing but P plus JQ, and this is S, sorry, this is S. What is the value of the P? 3, let this is the 3. What is the value of P? J4, let this is the J4. And then that is the, and we can find the resultant. This is the resultant, that is nothing but S. The magnitude of this line will give you the S. This is the P, Q, and this is the J. In which quadrant? This is called first quadrant, that is called the second quadrant, this is called the third quadrant, and that is called what? Fourth quadrant. We have the total fourth quadrant. If P is positive, Q is positive, that will be in first quadrant. And here it is, if the Q is positive, it is inductive and lagging. Circuit is what? Called lagging, because it is inductive. Now if the Q is negative, for example this is the minus JQ, 3 minus J4, this is the J4 minus. Now watch this, this is the 3 will remain same, real part, this is the imaginary part, that is the resultant. Now it is S. In which quadrant? Right, here we are getting the theta, here we are getting the theta. Theta will remain same, but if it is in fourth quadrant, it is what? Leading. It is capacitive in nature. Minus J4 plus J4. And now if it is in second or third quadrant, always remember, if it is in second and third quadrant, means what? P, that is the real part, is negative. If the real part is negative, means that particular circuit is not consuming the power. It will deliver the power to the what? Source. Now it is not a power absorbing circuit, it is power delivering circuit. That's why we are getting the P is equal to what? Negative. You heard about the negative resistance concept, right? Like tunnel diode, like gun diode. So that is, if it is in second quadrant and if it is in fourth quadrant, this means that the power factor P, in that case the P is negative. For example, minus 3 plus J4, that is in what? Second quadrant. This is the negative, means it will deliver this amount of power. So that is the concept, remember this. So this is about what? This is about complex power triangle. I want to give one question, right? Try to solve this question, use all this concept. Okay, now for example, just 2 minutes and get the command over this topic. We load, for a load, VRMS is equal to 110 angle 0, 85 degree, IRMS is equal to 0.4, 15 degree. Determine the complex and apparent power. If you want to determine the complex and apparent power, right? What is the complex power? Directly remember this formula, VRMS IRMS complex conjugate of this. it will become 110 angle 85 into 0.4 minus 15. Why minus 15? Because it is a complex. This angle will become negative. Multiply this and this will subtract it, and this is become 110 and 0.4 is 44. Angle is what? 70 degree. That is called as complex power. Answer 1. This is the complex power. Easy. All objective will be covered. In next class tomorrow we are going to discuss what some important numericals on that complex power. Then what is the apparent power? Apparent power is nothing but magnitude of this. What is the apparent power? 44 volt ampere. 44 volt ampere. It is complex power. The unit is again volt ampere. Complex power has the unit what? Volt ampere. Okay. Then the real power. It is also called useful power or effective power. This is given by S cos of what? Theta v minus theta I. What is the theta v minus theta I? Its angle is what? 85. Its angle is 15. That is what? 70. You can use 44 cos of 70 degree. It will give you what? Real power. You can calculate it. Very easy. What is the unit? Watt. What is the unit? Watt. Now, next question. What is the reactive power? Yes, reactive. Reactive power is given by S sine of theta v minus theta I. So this will become 44. Yes, that is the answer. 44 sine of 70. Sine of 70. Everyone please check and give me the answer. What is the answer for this question, everyone? Just I am using the calculation. Give me the answer. What is the answer for this question? 44 sine of 70. Now last, what is the power factor and what is the load impedance? Everyone. Give me 1 minute. Yes, बताइए आंसर क्या होगा? That is the last question, and you have the idea about that. When I am multiplying 44 with the cos 70, 44 into cos of 70, that will become 15.05, nearly equal to 15.05 watt. 15.05 watt. And you can multiply 44 into sine 70, 41.34 volt ampere reactive. That is the unit. 41 point, nearly equal to 41.35. Now last question, what is the power factor? P by S. Power factor P by S, or simply you can say this cos 70, because the theta v minus theta A is, so you can directly calculate the power factor. You have the two formula, P by what? S, or directly you can get the cos of what? 70 degree. Cos of 70 degree will give you the power factor. Now finally, what is the load impedance? Load impedance means simply Z. What is the Z? V by I. What is the V by I? Here we have 110 divided by 0.4. 110 angle of at 85 degree divided by 0.4 angle of what? 15 degree. Now 110 divided by 0.4, 275 angle of 70 degree, but sometimes real part and imaginary part you want 275 cos of 70 plus j 275 sine of 70 degree. in degree calculator, it should be in degree mode, and you will get the answer what is the real part and what is the imaginary part of the z. I am giving you the answer that imaginary real part is 94.06, 94.06, and the imaginary part is around 258.4. Very easy calculation. So here it is the positive, here it is positive, means which quadrant? First quadrant. And current lags voltage, I lags V by what? 70 degree. That's why it is inductive circuit. That's why it is what? Inductive circuit. We are getting the Q positive. It is in first quadrant. Everything is clear with this numerical. Please revise this numerical. This is very, very important one. And in next session, means tomorrow, we are going to discuss important numericals on complex power or apparent power, effective power, reactive power. Okay. So please stay tuned with us. You are on BYJU'S exam prep, most comprehensive app for all exams. Right. Thank you for attending the session. Like the session, subscribe the session, and share the link of this session. Thank you and good luck for coming exams. Thank you.